Okay, we're going to have a short little video about divergence. Divergence is another way that we can take derivatives of vector fields. Both curl and divergence have physical meanings. Curl is kind of, if the vector field represents fluid velocity, the curl represents how much the vector field is spinning at a point, locally, not overall, but locally at a point. Divergence of a vector field at a point represents how much the vector field is spreading out or going into a certain point. We'll discuss these more later when we can talk about the Stokes theorem and divergence theorem. But I just mention that for now, and you can look up other videos that explain it as well. So the divergence of a vector field is going to be equal to the gradient dotted with the vector field. Now, unlike curl, the divergence can be defined for any vector field over R anything, R2, R3, R4, whatever. Okay, so in particular, what this means is the divergence if F is equal to, let's do it in R3, PQR, then divergence of F, this means divergent of F is just equal to PX plus QY plus RZ. So we use this to let us know that. So gradient, we think about this as being a vector of partial derivative operators. And when we dot this with P, Q, R, we just get this up here. Partial derivative with respect to x of P. So again, this is Px plus the partial derivative of Q with respect to y plus the partial derivative of R with respect to Z. Okay. So what can some of these, what are some aspects of the divergence? Like I said, there's a physical interpretation and motivation for this that we're not going to talk about until later. So sorry. So one thing that we know is that the divergence of the curl of a vector field is equal to 0. Okay, and I'm going to let you prove that, but it's just by Clairault's theorem. Okay, this is an exercise that you can prove. Just write out what the definitions of these are and prove it. But let me just, what does this mean? Let's write out what this means. This is gradient dotted with the curl of F, and this is just equal to the gradient dotted with gradient cross F. Okay, now we're saying that this is equal to 0, but remember also, we talked a little bit about the scalar triple product. This is also equal to 0. This is true for vectors, and we're saying that this is also true for these differential operators on vector fields. So it's nice that it kind of works out that way for us. Okay, so for example, let's look at an example. Let's say F is equal to the vector field x, z, x, y, z minus y squared. Okay, then the divergence of F, let me come down here. Divergence of F is equal to the gradient dotted with F. I'm just going to write all of this out. This is partial x, partial y, partial z, dotted with F, which is xz, xyz, minus y squared. So this, the partial derivative of xz, the partial derivative of xz with respect to x is z. The partial derivative of xyz with respect to y is xz, and the partial derivative of minus y squared with respect to z is 0. Okay, so the divergence of f is equal to z plus xz. Okay, so the divergence of a vector field is a number. The curl of a vector field is another vector field. The divergence of a vector field is a scalar valued function. Okay, so that's why the divergence of the curl of a vector field makes sense, but the curl of a divergence doesn't make sense. So div curl makes sense because div is an operator that you do on vector fields. Curl of f is a vector field, but let me just write this down here. Curl, I'm going to write it in red so we know not to do this. Curl div is not defined. Why is that? The divergence of a vector field is a scalar valued function, but the curl of a scalar valued function doesn't make any sense. And so on the homework, you'll have a bunch of questions like this where it says, is the divergence of the curl defined? Is the curl of the divergence defined? And stuff like that. You'll see it on the homework. Okay. So notice that the divergence of f is not equal to 0. So this means that f is not the curl of a vector field. Because if f was the curl of some other vector field, like let's say f is equal to the curl of g, well, this equation says that the divergence of f would be equal to 0, because the divergence of any curl field is equal to 0. But the divergence of f is not equal to 0, therefore f is not a curl field. In other words, f is not the curl of a vector field. Okay, one other thing, one other operation that I wanted to denote or introduce is this is the Laplace operator. So here f is a scalar valued function. So, okay, f is a scalar valued function. So in other words, it's a real valued function of, it could be 3 variables, 4 variables, however many you want. Okay, this is the upside down. This is an upside down triangle. So these gradients, the flat part of the triangle is on top. The pointy part of the triangle on top is on top. And this is defined to be the gradient squared f, or gradient dotted with gradient of f. So this would be, so let's do this for 3 variables. This would be partial x, partial y, partial z, dotted with the gradient of f, fx, fy, fz, and this is just equal to the second x derivative plus the second y derivative plus the second z derivative. Okay, this is something called the Laplace operator, and it comes up a lot in physics. Okay, that is all that I want to say about divergence at this point. You can, actually no, there's one more thing that I want to say, so hold on. Okay, so I told you how to find the Laplace. I defined the Laplace operator applied to a scalar valued function. We can also define the Laplace operator on a vector field, and this is just going to be the Laplace operator of the components. So Laplace P, Laplace Q, Laplace R. Okay, so if f is equal to PQR, the Laplacian of the vector field is just this right here, the Laplacian of each one of the components. Okay, so to summarize, the curl of a vector field is a vector field. The divergence of a vector field is a scalar valued function. Okay, the Laplacian of a scalar valued function is a scalar valued function. The Laplacian of a vector field is a vector field. And really, I should have already done this. The gradient of a scalar valued function is a vector field. Curl is only defined for a vector field. Divergence is only defined for a vector field. Okay, and now that's all that I want to say.